So I'm going to move on now to the next section, and that's going to be what the frequencies were that Rife used, that Hoyland wrote down. And once again, I'm going to say that Hoyland hid these by doing this sideband method that we talked about earlier. And then, of course, you saw in the earlier segment how the sidebands show up on the spectrum analyzer. Okay, so these were the known frequencies in hertz. So you can see the lowest frequency here is 191.803 hertz. And that's in the radio band. So that would be at the very, in fact, that's below the radio band. All right? And then we move up to the next one, which is anthrax. See, the bacteria is getting bigger. Mm-hmm. So this frequency is getting lower.
Okay.
So the lowest one is anthrax at 139,200.
Okay.
And then we go to B or E. coli rod at 416,510. Now this is, after you multiply this frequency out, this is what you get that you're going to subtract from the fundamental frequency. And then you're going to get this different frequency here, and then ever how many times you divide it, you're going to get this audio frequency. So I think I've covered that earlier. So as you can see, the highest known frequency that Hoyland knew about, along with Rife after he remeasured it, was the cancer frequency, which is 1607450. Mm-hmm. And again, it's showing you that if you do this, now one thing that I have to point out, that the carrier frequency here is at 3.1 megahertz. And so the max audio frequency that I'm going to run to is between 10,000 and 70,000. So when you put 70,000 into the sideband calculator, which is going to print out a paper, and it's going to tell me exactly what these frequencies are that I need to do my sweep in. So that's all part of in the little paper.
Which paper?
Well, it's in the little paper that's in the booklet.
Oh, okay.
And the thing is that what we want to do here is, as I pointed out earlier, see, I am not a firm believer that I absolutely have to have the frequency exactly like this.
Because you're going to sweep it?
Because I'm going to sweep it, and I'm going to find it, and I've got a spectrum analyzer, and I can see it. Mm-hmm. So I can see where this frequency is going to end up.
Yeah.
Exactly. And I can put a dot there, and I can sweep, and I can see how many times it hits that. Maybe we should revisit that in a minute.
Okay.
Over there so that they can see what I'm talking about. But see these audio frequencies over here in the chart? These are all the audio frequencies that I need to do. In other words, in my sweep. That's why I'm sweeping the sine wave generator or the square wave generator between this frequency and the highest frequency.
So 31 is the lowest one and 69 is the highest?
Yeah, is what it looks like right in here.
Okay.
And see, that's typhoid. And see these little blue indicators?
Yeah.
That's indicating it's a virus to me.
Okay.
So the two most important are the two most dangerous. The most dangerous is tuberculosis, because you not only have to kill the rod, you have to kill the virus. There's a rod and there's a virus. Rife called it a rod.
Okay.
Looks like a rod in the microscope.
Yeah, in the microscope. So it's mandatory that you do both of these frequencies at the same time, or one right after the other. That's why the sweep. All right, because you can see there's not much difference here between them. The virus is here.
Right.
This is where we're going to end. This is what Rife determined, or Hoyland determined, was the frequency in the lab. And the other thing that I'm going to point out is Hoyland, when he made the sideband machine, it was tested in the laboratory. And then it was given to the doctors and it was tested so that they know that this method works.
Okay.
So here's all your difference frequencies in the chart.
One quick question.
Yeah.
I see under typhoid rod, you've got 2 numbers.
Yes. I got the 2 numbers because you got to do these 2 numbers.
Okay.
You have to do, this is the only known virus. You know, tuberculosis is the only known thing that if you kill the rod, what's going to happen is the patient's going to die because then the virus is going to take over and it's going to eat you up.
Okay.
So you know there's 2 frequencies there from Rife's original lab work?
Yes. Yes, and Rife stated in the movies and the films and the talks that you must kill the rod and you must kill the virus. So he developed a machine that did those 2 frequencies at one time. There's the 2 numbers. See that, Tony?
Yeah.
Yeah.
There's the 2 numbers.
Yeah.
Now it's correct.
That's the rod and the virus.
Yeah, that's why I got the blue there.
Yeah.
So I see what happened as I went down
Yeah.
the chart. I just transposed a number.
Okay.
Anyway, this is what was known.
Okay.
Period. This is all they knew about. There were probably 15 more. That, who knows where that went.
Right.
So anyway, I'm going to go back to this. I'm going to go through this one more time. These are the only known frequencies for these viruses that we have today. The rest of the notes have been lost.
Okay.
Nobody knows where they're at, so we don't know.
Okay.
Because the machines are gone and nobody can find the other machines. The only machine that was found was the one that I suspect was in LA that Jeff Garf got from Dr. Lowe.
Okay.
And I've never seen anything. I've heard about it and I see some spectrum analysis, but my interest would be in, with that machine, would be to run it and have the real spectrum analyzer and see if you're absolutely going to end up.
Who was Jeff Garf again?
Jeff Garf was very interested in Rife in the beginning, and he's the one that wrote the history of Rife in the PDF file on the internet. And when I was talking to him, he explained that he finally found a machine and he was able to figure out what was going on with it. But through my research, well, first of all, Jeff Garf, let's just say what he does. He produces the GB4000 and the Mopai amplifier. Those are two things that you can buy right now on the internet.
And they're
right, but there's no guarantees or anything because remember, we're not medical doctors.
Right.
We're only reproducing this guy's work, and if you want to do experiments with it, then that's what you're going to do. Now, the thing about it is this work requires, I would really recommend the person doing this kind of work to have a spectrum analyzer. Or they're not going to be able to see. You're just second guessing.
Yeah.
You're saying, yeah, we got the wave shape on the scope. The scope is not telling you what bands it's generating. So I think what we'll do is we'll cut away from here for a minute and we'll go back to the analyzer.
Okay.
All right. So anyway, we're here at the analyzer. And what we want the machine to do right at this point in time, and I'm going to point out some parts in the machine here, and this is very important because this is your fundamental oscillator.
This is your replication of your version.
Well, this is programmed to do the...
no, but this is a Rife machine.
Yes, this is a Rife
Built by Bedini.
Yes, along with this entails the pump wave in it. So if I turn this on, right away you can see this appear. That's your fundamental frequency. Now, if you look at this we know that this is the cancer frequency because we've determined that by over there on the other chart. So now if we hit the marker, well, let's auto it and hit the marker. Okay, so there's our fundamental frequency, and see all this? We're not modulating at all. So now if we hit the marker button, it appears there, and it's telling us, okay, we're sitting at, see right at the peak of this wave, we're sitting at 3.099999, which is 3.1 megahertz.
Okay.
All right, now, when the frequencies are put into the machine, it's going to modulate these against the RF amplifier, which is going to create sidebands here.
So this is that little $100.
Yeah.
What do you call that thing?
Generator. And see, you could see that the sidebands appeared for a second. Watch, they'll pop in there when the oscillator comes down a little bit. See them?
Yep.
Okay, now, so what we're going to do with this is we're going to, actually we want to zoom out because we want to see what all of them that it's generating. Okay. So see all the sidebands that it's generating?
Mm-hmm.
So what we can do is we can take this marker and we know what the cancer frequency, we know it's 3.14. So let me have that chart just for a minute there, Michael. And I'll just point it out here. What we're looking for is we're looking for the BX sarcoma virus, and that's 3214900. So all we have to do is move this marker. Okay, so we want 3214. 832, we're within 1/10 of 1 meter right there. And you can see that now the spectrum analyzer shows you this dot. And see, it's hitting those peaks as it goes towards the fundamental. And each time it hits that peak, you're actually hitting the cancer virus. So we'll bring this down. Sometimes it's hard to adjust this, but we'll get it. We don't need that much attenuation. Or I want you to get a good picture of this so you can see where they're going. And I'll zoom this in a little bit. See if I can get this where I want it. See all the bands that are showing up in there, Tony?
Mm-hmm.
So let's get it down here. My electrodes are goofing me up here, so let me get this right here. I want to hold them together so you can see. As it generates those bands as it moves, see that dot moving up and down? It's hitting the cancer frequency at those every time that dot appears. But it's also hitting all these others. So if we chose another frequency, like, let's see if we can go down here. Marker. Two 915. So we're at 2915. So we're at B or E. coli rod every time that dot hits on top of one of those peaks. See it? So it's sweeping the whole band.
Yeah.
So we could move this in. So we get a little better picture of this as these sweep out. There you go. And this really machine wants to be in resonance, so it wants you to be on the machine. See it? So it's already hit it there, it's hit it there. It's hit Bedini, E. coli there. So now if we just take another one to show you that it's hitting well, 30594. So we just take the marker and go to 30. Now we are hitting, every time that dot hits this peak, we are hitting BY sarcoma, which would be skin cancer. If you could put it right on there. You follow me? Mm-hmm. So let's pick another one and see where we are. Okay, 2.
So just to, you said you've kind of shorted out the electrodes here, or the
well,
pads?
I want the electrodes. See, they want to be hooked to something that
Right.
You're seeing the pump wave and you're seeing noise enter. They want to be hooked to you. See, so you get a perfect wave. Watch
Okay.
as it comes out.
To complete the circuit.
Yeah, see it?
Yeah.
Now you're seeing the real sideband waves. And it doesn't make any difference. What I found out with this is that if I put these together like that, it shows you a pretty good picture, see?
Yeah.
And that's why I have detuned the circuit. I've detuned the circuit in this machine for the simple fact is once it's on you, it tunes.
Right.
And I can make this as small or as wide as I want. Right now I'm in the noise, but let's see if I can get this amp. There you go. That's a pretty good picture of how they go out. See?
Uh-huh.
You're starting at a real low frequency and you're ending up at a real high frequency. So what I want to do is I'll put this under here for a second so it stays there. And I'll pick another one. I'll pick pneumonia or spinal meningitis. That would be at 2988.034. So I'll hit the marker. 298. Eight. .107, but see, since I'm sweeping, see, I'm hitting it all the time there. I hit it twice here. Once there, and once when it moves there. I actually hit it a couple of times, see it? They're down lower here. So now what we should do is probably span it in there so you can see it hit it right at the top of the peak when it gets right at the right frequency. See?
When it's at the top of the peak of the
Yeah,
sound
see?
wave, when it hits it?
See it hit it?
Yeah.
Now watch as it grows.
It grows into a vertical.
See it hit it there, it hit it there. It's going to hit it there.
There you go.
And then it's going to go down here and collapse. And then it's going to come back and sweep again and hit it.
Right.
And hit it. And that would be your pneumonia, according to Hoyland. Now, let's go down and see if we can get syphilis, which is at 3.154. So we'll go to the marker 4 there. We're within 1/10. Now you can see that it's coming along and it's hitting it right there. See it? Then it's going to grow again, so it's hitting it every time it hits. See how it sweeps by?
Mm-hmm.
So it's sweeping the range, and that's what Rife said, or the doctor said, that they had to sweep the machine back and forth, and then they got great results. So we're just doing it to show you that the sweep is hitting these frequencies. I think we can close this down. Now, this, of course, you can see the sweep here and the gating effect. And this little wiggle that you're seeing here, see the gating effect in there? That little wiggle you're seeing is this pump wave. Okay, so if we took the scope, and we'll go over to the pump wave. That's your pump wave. Now let's go over here. And you see how the pump wave is making it move up and down? Might be really hard to see that on there. But it's that wiggle that's in there. Can you get that, Tony? So let's come out of the oscillator and look at it. Okay, there's the pump. So you can see the wave. Mm-hmm. So it's just on and off, on and off, on and off. Mm-hmm. And that pump wave is then being sent out to the electrodes. And you can see that in the pump wave are the frequencies.
So that's
the whole band of frequencies.
That's what would be going into your body.
Yes.
Yeah.
And it's using that little bit of DC current to push it through your body.
When you say gating effect, does that mean where it goes into the body?
Yeah. See, the most important part is, are you generating these sidebands? And this is why it's important to see the spectrum analyzer, so that you know that it's actually hitting it. And every time you see this jump, that's the pump wave. That's this ripple effect. It's there. You see it moving up and down? Mm-hmm. Okay, and it's very important. See, I just changed the resonance of it, and I changed the resonance down here because I'm holding the electrodes. So now I've got clean waves, see it? When it pops up, watch. If I let go of it and I separate the electrodes, then I'm just going to get what I get. It's going to bounce around. Because there's a pump wave involved and it's pumping it. That's a DC current. And then if I take the electrodes and I put them together like this, you can see my waves are cleaner. Shows you more.
Yeah. More regular.
Yeah. And each time that dot is going to the peak of this, right?
Right.
Then I'm hitting that exact frequency.
It's on the peak.
Yeah, now I think the lowest one is 139, so that would be 3062. There, 465. So now every time that hits on the peak, like right there, mm-hmm. Remember this is the lowest one. Mm-hmm. So it's going to hit it one time. Actually 2 times, 3 times. Mm.
Yeah, it's moving a lot slower.
Yeah. And that would be anthrax.
Wow.
So I'm hitting the whole spectrum of what I have here.
Yeah.
And I can change that by changing the generator.
Right.
In other words, if I change it from 70,000 hertz to something else,
right.
Then my sideband calculator is going to change.
Right, it changes.
And what I'd like to do, if possible, Tony, is it possible to do the computer screen so I can show you the sideband calculator?
Sure.
Okay.
Okay, what are we doing now, John?
I'm going to run the sideband calculator. Now, what I want to tell everybody is you can only get this calculator off the right groups. You have to join the group to get it. So here I'm going to run the calculator and show you. Here's the carrier frequency, which I had over on the other chart. So I'm going to put 31 right there. That gives me 3.1 megahertz. And see, my max audio frequency is going to be 70,000. So I'm just going to make that 7. And then I'm going to tell it to calculate, and these numbers are going to change. So now you can see that the BX frequency still maintains 3.214900, and the difference frequency is 114, which I showed you in the calculation. Audio 1 is 57, but if I put this back to 40, it's going to be where I told you it was on the chart over there. Now, if we choose the sarcoma frequency, right? Mm-hmm. And we tell it, give us the graph. You can see this is what the wave looks like, gated, which you saw there. And then it's going to be 1, 2 here, over.
Right.
Wow.
So if I divide it by 3, it's going to be here. If I divide it by 4, it's going to be there.
So who put all this stuff in the Rife group then?
There was a computer programmer that made this program after they figured out how the machine actually worked.
It's nice.
And so it actually works out pretty good, because if I get out of here and I put this back to 40, say I only want to run my generator to 40,000, and I recalculate for this same cancer frequency, and I go to the graph, I'm exactly where I want to be when I divide by 3.
Nice.
1, 2, 3. So if I change the generator, as long as I get this number,
Yeah.
as long as I get this number, which is 3214.900, you see here, it's saying it's divided by 3 here.
Uh-huh.
So my spectrum analyzer is showing me those numbers, and what's being, once again, here's the fundamental frequency. We'll mark it. We'll auto this first, and then we'll bring it in. So we know that's it, right? And then we'll span this in so that we can see there's nothing being generated. In other words, we're not generating anything here.
Right.
All right, then we mark this. It's telling me, according to my span, where my generator is, see?
Mm-hmm.
So there's my fundamental frequency. All right? And then I say to it, start generating the sidebands. There you go.
Mm-hmm.
See, my fundamental frequency is not changing.
No.
What's changing are the sidebands. So now if I just say marker, and I know that the cancer frequency is going to be over at the 3rd band, so that's going to be 214 or 3214, which is going to be here. 3214.
Right.
I'm within still 1/10 of 1 meter. You can see the dot, how many times it hits the actual frequency. See it?
Right.
So then we can just span this in, Tony, so we can get a tighter view of how many times this is going to happen. See?
Mm-hmm.
So I know it's right.
Hitting it regular.
Yep. And that's all I have to do.
Mm-hmm.
And then, of course, this is going to change. If I take these off and I put 1 here, and one here, then you're going to see a much
Right.
more detailed wave. See it?
And more regular.
Yeah. Because it's now in tune with me.
Right. Yeah, it's performing nicely.
Yes. And the jumping up and down is this pump wave here. So I think everybody gets the idea.
Right.
And just to reiterate,
Yeah.
this here is your solid state version
Yes.
of the Rife machine,
Of the Rife machine. And
which we'll get into later on.
yeah, well, it's in the book,
Yeah,
in the booklet.
yeah.
But like I said, the important part was programming this for a fundamental frequency and then getting the audio circuit to, and the pump wave, to put the DC current through you.
It's beautiful.
So if you take the generator off, you should come back to the fundamental frequency. And the pump wave is a square wave. See? Now by changing this, right? By changing the span, I'm either going to come down 1.66 or I'm going to go up. See? So the thing is to auto it, and let's find out where the marker says it is. And there it is. 3.100000, so it's right on.
Right.
And there's the wave.
Beautiful.
And you can see the pump now because you can see it going up and down.
Right. Right.
That's the DC pump.
And that's the sweep.
Nope, it's not
No.
sweeping. It's just a one steady frequency, the fundamental.
Because it's up at the top. Of
Yeah,
the,
what you're seeing there is the pump wave pump it.
I see.
So the minute you add the generator to it, watch what's going to happen there.
Then it sweeps.
Well, watch as soon as it comes on.
Yeah.
You see, and then you can see what it's doing here.
Right.
As it moves to the, see how many bands it's generating?
Yeah.
And so that's saying that please zoom out so you get more. The machine can actually tell you, okay, zoom out a little bit
Right.
more. Now there it goes. See, it's going. So we'll zoom in. And we'll get these so that we get a nice wave, see? And it says the span's at 200 kilohertz. So mark it. There's the, notice the fundamental frequency is not changing at all,
Right.
even though it's being pumped.
Right.
So I think everybody's got a pretty good idea of how this is working.
Right.
So we'll go back and I'll explain it one more time over here. And then we'll move on to the circuits. Okay, so now we're going to move on to more technical in the Rife machine, the building blocks for the Rife machine. So the first building block is the fundamental oscillator. Now this is a programmable oscillator that you have to buy and you have to program it. So you need a programmer to program it. And it's programmed and it's a CCP C4, which you can get at DigiKey. And I think you give them a little bit and they'll program that frequency for you.
Who? DigiKey?
DigiKey Electronics. They're on the internet. And it's very important to remember with this type of CMOS oscillator, I think it does CMOS and TTL, and that you regulate it to 5 volts, so you need a regulator in the circuit, and you can see that right here. And you need the filter capacitor here of 1,000 mics on the input from the 12 volt source. You want to keep this as stable as you can from the 12 volt lithium cells. And this is giving you your fundamental frequency in a square wave. Now, whether we're using square waves or we're using sine waves, we're still going to get the same thing. We're just going to get more of them with a square wave because it's odd harmonics. And to protect this guy, this oscillator, we built a buffer circuit for it, which takes the RF and buffers it so that there's a safety factor, so that it comes out of the emitter at low impedance. So it's going to drive the RF circuit from this point here. And these are just common variety transistors. This can be a 2N2222, a 2N4401, or anything that's got, you know, a high HFE, which is high frequency gain bandwidth. And so this becomes your buffer circuit, and this is going to drive your RF amplifier. Now, the RF amplifier is just done really simple. It's biased with a 10K resistor. It's got an inductor where it belongs. It's got a resistor in the emitter. And it's got a pi network, so it's tunable. In my case, I detuned it. I detuned it for the simple reason is when you touch it, it goes into tune. So it's set to go into tune the minute you touch the electrodes.
Okay.
To give you the best results. And so this transistor here is very important because this is a regular RF transistor and it needs to have a heat sink on it, which I'll show you when I bring out the machine in a few minutes, and I'll point out all the what the components are. These are trimmable capacitors that adjust this pi network. Now normally this network would be higher than 22 microhenries, but since I wanted it detuned, because I want you to make up part of the resonance circuit, I made this as small as I could get away with. But I made this as big as I could get away with for current through here. So, the thing about this RF amplifier is this RF amplifier must include the pump wave and the modulating wave. And you can see right down here at the base, there's a 2.5 millihenry choke. And that choke then connects over here to the audio amplifier, like this. So when you put the audio frequency in here, this gates this transistor, which puts a space in between what the oscillator is putting out from the buffer in here. So it's like it shorts it to ground for a minute and comes back. So this allows you to generate the sidebands. This circuit here and this. This is how you generate the sidebands, by putting the audio frequency in here. But it's not what I would call an audio frequency from 20 to 20 kilohertz, because it's 10 kilohertz to 70 kilohertz is how you're going to get Rife's frequencies. So this amplifier has to be capable of doing 70 kilohertz. In other words, there can't be anything where it's not the same as if it's doing 10 kilohertz. It has to be flat. The next part of the circuit that's very important is the pump wave oscillator. And if you look at this very closely, the 555 timer sends out a pulse at about 14 hertz. So it's a square wave at 14 hertz, and turns this transistor on, lets the current go through it. And this, of course, this piece ends up being connected right here. Now to limit, to not have any of the RF come back through the circuit to the oscillator, there's a choke here. That's also selected for minimum, so that when you touch it, you're in resonance. The 47K resistor limits the current that can go through your body. Because you only want 2 milliamps or 3 milliamps. You don't want anything more than that. Because the DC is what allows the frequency to get in. And this is why this is really not like a Rife machine. It's more like a Peoria machine. And so I call it Bedini, Rife, Peoria, or whatever you want to call it. But this is what allows you to get the signal through your body, is this pump wave. And without this pump wave, then you're at the limit of however far the RF can penetrate in your body. And that's not going to be very far, because maybe about 2 inches. I mean, you can change this around and make it more powerful to where it'll light a light bulb, but I'm not into burning anybody. I don't want anybody to get hurt or anything like that by getting an RF burn. RF burns aren't funny. They're blotches that never go away in your skin. So that's exactly why I've done the circuit like this, is limiting this thing to maybe 1 watt or 2 watts maximum under resonance. It's 20 volts peak to peak, so I mean it's got plenty of RF. And the only other thing you could do with this is, if you wanted to boost this, then you'd build an RF amplifier and put it here, and you would burn yourself up. Sooner or later you're going to put too much RF and you're going to feel that.
What is a millihenry?
Millihenry.
Yeah.
Millihenries, they're chokes.
Okay.
They're in millihenries and microhenries, and it would be a choke that big, and what it is wound wire around a ceramic, and it becomes an inductor.
Okay.
And so that inductor is basically sitting right here in the circuit.
Okay.
And then the resistor's sitting right here, and then there's another inductor that's sitting right here. And trimmable capacitors are, they're a little bit different.
Well, just backing up, an ohm is like a measurement of resistance.
Yeah.
A Henry is a measurement of capacitance.
Of inductance.
Inductance, pardon me.
Yeah.
Inductance.
Anyway, a trimmable capacitor, see, has a...
It's tiny, yeah.
Yeah, it's a very tiny thing in the circuit. And it allows you to adjust the capacitance, and that's why you see, these arrows through these capacitors. And these are actually sitting in the circuit like this.
Yeah.
So see, usually when I draw things, it's a circuit the way I'm going to lay it out.
Yeah.
Exactly the way I'm going to lay it out.
Okay.
So basically your pump wave looks like this. It comes on at 0, goes up to its 12 or 11.5 volts, and then the RF oscillator, this pump wave, when it starts to pump this, it ends up here with a DC pulse, and what ends up on the DC pulse is this, which are the sidebands.
Okay.
And so now it's on the DC. And that's how you get it in there. That's how you get it into the body.
John, could you just read off the values on
Yeah.
the pump wave circuit? One of them is a little bit small.
Okay. The 12 volt line. Okay, this capacitor right here is 0.47.
0.47, is it?
Yeah.
Okay.
And then there's 100 ohms, 10K, and 4.7 microfarads.
Right. Yeah, got it.
And that sets you at about 14 hertz. And then the transistor, just a garden variety, 2N4401 or 2N2222, where the current's coming out of the emitter and then going up to the 47K and through the 22 microhenry choke. And a 22 microhenry choke, you can get them on the internet, And you can see that they're not very big.
Uh-huh, yeah,
And that's actually sitting right here across here.
okay,
Of course, this being the bigger one, and then another 22 here.
right,
These two are kept the same. Now this 2.5 millihenries blocks the RF because the RF amplifier is getting RF from the buffer circuit, see? So it blocks the RF going in back into the audio circuit. So you only push forward is a good way to say that. And that 22 is sort of a big part,
right,
and that would go right there.
yeah, okay,
So that's pretty big
yeah,
for the circuit, and that's what's blocking the RF, allowing the audio to get gated. And so what's happening is the audio is gating this RF transistor off and on to produce the sidebands. It's actually distorting the wave,
okay,
which if you were to watch it, it wouldn't look perfect. It would be distorted.
yeah,
So that's the basic functioning of the whole circuit. I mean, if you put this together and you have a spectrum analyzer and you have a sweep generator and you program it, you're going to get exactly what we just showed you.
yeah,
First of all, I'm going to explain to everybody that I'm not a medical doctor, and that you build this machine, or you, from my research work, which I'm presenting on this film, and that I make no guarantee at all for anything that you do or you do to anybody else if you build this.
so you make no claims on this?
I make no claims whatsoever, but I want to also explain to everybody that this is not your normal Rife machine. This is a mixture. This is a machine from my research work which indicates that it works far better with a pump wave involved in it, and that's a small DC current that's pumped that allows the frequencies to actually get into your body, where Rife's machine, you had to be within so many inches of your body with the tube. And for the RF then to penetrate you, you have to have power in wattage. So Rife's machine was 50 watts max until he hired the new engineer and they started to bring it up.
That was Hoyland, was it?
Yeah, Hoyle, and I think the highest, 400 watts is a lot to be putting into a ray tube. Now, the other thing is that you don't need the ray tube. It doesn't make any difference how you get the RF into you. So I'm in a disagreement with a lot of things, like power and everything else. For the simple fact is I always worked in milliamps and microamperes with my machines and got results by using electrodes. So it's not that John Crane's, I want to make it known that it's not that John's Crane machine wouldn't have worked. It would have worked if he would have had that fundamental frequency and he could have gotten the sidebands.
In your opinion?
Yeah, no.
No?
In true reality, you
Okay.
need the sidebands because, as you will see in this DVD, if you're watching it now, you will see how the sidebands appear on the spectrum analyzer and exactly what's happening. And the other thing that I'm going to point out is nobody really knows, because there really isn't a record of who got cured and how long that cure lasted with a Rife or anything. Nobody's, with a Peoria machine, there are records. You can research those records, and it was documented very well because it was done by the French.
Right.
Yeah, and they're on Tom Bearden's website.
Yes. They're on, Tom Bearden's website. All those papers. And my discussion on this machine is basically my research and how I combine the two machines together to form a new machine. And the other thing is that I'm not so common, when it comes to complicated stuff. I don't like complicated stuff. So I like to simplify the circuit as much as possible, because all you need is the effect. And that effect, you will see as you get into this DVD, is it will produce the sidebands that it needs to produce. And that's all you need. Now the next thing you need is you need to get this into the cells, because I have to agree with Tom Bearden on this. Let me give you an explanation of me when it comes to electronic circuits. I'm not one that likes complicated circuits. I feel that you can reduce everything to simplicity. In other words, as long as you achieve the results, as long as the scope's showing you the results, as long as the analyzer's showing you the results, and mysteriously, if the results work, then why do you need something that's so complicated? There are machines out there that are so difficult to build that nobody could build them. And if we really think about it today, we can do things with oscillators that we can program ourselves. We can do things with the transistors that we got. And so I'm not one that's going to make a very complicated circuit. And I want everybody to understand that. I'm going to reduce it to its simplest form so that it becomes to where anybody can make it. In other words, I would prefer that you had skills, and I would prefer that you had the equipment to check it. Otherwise, you're just stabbing in the dark. Or buy it from somebody that's going to make it that has tested it. So the final thing here is the batteries for this unit, and I'm going to say this, that I would prefer that where the battery is concerned, that you use a lithium iron phosphate. A lithium iron phosphate battery, you can buy at Home Depot or any garden center that sells solar lights. Now these happen to be 1 amp hour each. I would prefer that you use 4 of these batteries. They're 3.2 volts each. You use 4 of them, you're going to get up to the 12 volts that you need to operate this machine, and it's going to run for a long time. Because, as I said, I am not one that uses massive currents. I'm looking for the results on the analyzers. So, with that said, I'm going to get into the charger for it, which is an LM317. Now, these are adjustable voltage regulators. And I've fixed this one where I want these batteries to be. So, if you look here very closely, there's a diode right here. This is very important. If you do not put this in, thinking you can just run the regulator to charge the batteries, and you disconnect the transformer that's charging them, when you come back tomorrow, the batteries are going to be dead. And then you're going to be replacing these. You don't want to run these to 0. When you run this type battery to 0, you run the risk, in other words, you run it right down to 0, you run the risk of this cell will not operate after that. Now, the reason that you don't really run it to 0 in a solar light when they put them in there is because the LED is at 2.8 volts. So the minute there isn't enough voltage to run the LED, you're not drawing anything from the battery.
Okay.
So that's the little trick there. So you absolutely need this diode in the circuit if you're going to make this charging circuit. And you absolutely need 18 volts DC so that this regulator can operate. And the max charge that you want to put on this battery is 14.80. So I've chosen some resistors here that will get you exactly in the ballpark. A 220 ohm here and a 3.1K here. Now this is sort of an oddball resistor, because you just don't go to Radio Shack and buy a 3.1K resistor unless they have them in percentages. So you're going to need to order that resistor. And you're going to need to find a heat sink for this, because when you put the 18 volts, it's going to heat up. It's thermal protected and it's current protected. So if a short happens here in the battery, this will protect itself. But it's mandatory for the diode, or you're just not going to be able to charge this machine. And that's what I want to say on the charger. Okay, so what I want to bring up here, Pat, is Peoria.
Okay.
As I said, he is the most documented. It's on the Tom Bearden website. Anybody can read this information. I mean, when the military gets involved, you know, in healing devices, then you know that something's working.
Yeah.
Yeah, well, the U.S. Office of Naval Intelligence went over there and wrote a report on it, which is on the Tom Bearden website.
Right, exactly.
In 1978, I believe it was, wasn't it? Thereabouts.
Yeah.
And the French Academy of Sciences were behind it.
Yeah.
The mayor of Bordeaux laid the cornerstone for the facility, and then he got to be premier of France, Jacques Chalbin-Demas, and he opened up the Priori facility. The premier of France opened up the facility. So this was not inconsequential, and France's the permanent secretary of the Academy of Sciences sponsored it, and France's leading immunologist did the tests on the rats and rabbits and whatever.
Exactly. Now, see, technically, this really is not a Rife machine.
Uh-huh.
It's using Rife's, Hoyland's sideband frequencies, but think about this just for a second. Peoria was mixing all these different microwaves together in this gas tube, which did the exact same thing that Hoyland was doing with the sidebands. And the thing about Peoria is he could penetrate the cells perfectly because of the rippling magnetic field, which that magnetic field gathered those frequencies and sent it through your body. And this was my discussion with Tom Bearden, that the pump wave is a very important piece of this whole thing. And as I was saying in the beginning, I like to simplify things. I like to have a simple oscillator that's doing just what it needs to do. I like to have a simple buffer that's doing just what it needs to do. I like to have a simple audio circuit, which is in Class A, that's just doing what it needs to do. And I like to have a simple RF amplifier and a simple pump wave oscillator. And it's very important that before we get into our discussion that everybody understands this, that we need to simplify this. This has to be something that you can have
Yeah.
you know, that you can make. And if you need to charge it with a solar, then you charge it with solar. If you need to charge it by the wall, you charge it by the wall. But what you do not want to have to do is try to adjust things like in Rife's machine, where nobody knew exactly what the frequency was, so they had to sweep the frequency back and forth, and that's the other thing. It's the sweep generator. And Michael, can you hand me that blue generator that's on the bench there? This is a very important piece of equipment, and it's only like $127. And you set this thing to sweep, you know, from 10 kilohertz to 70 kilohertz, then you know that you're hitting all these side bands that hit the viruses and the bacteria. Anyway, now that we understand, you know, what this thing's going to be,
Okay.
that not only was the rippling magnetic field very important, but Peori discovered aboard ship that there was some fruit laying next to a microwave dish. And when they were running the microwave, that fruit never rotted aboard the ship. So it must have killed all the bacteria, and I can understand where he took it from there. And Tony, do you have anything to add to that?
Not really. I think he was. I think he was a radar operator in World War II.
Yeah.
And they stored the vegetables up behind all the electrical equipment, and as you said, that's where it came from. And he was also a member of the French Resistance, as was the future Mayor of Bordeaux, who got to be Premier of France. So they were kind of buddies.
Yeah.
And because of that, he got a lot of backing from the government when Jacques Chalbon-Demas was voted into either, first of all, Mayor of Bordeaux and then Premier of France. And it's worth noting that Priori wrote a PhD on this. It's on Tom Bearden's website. And he also had 2 U.S. patents on it. So this is not a big secret.
Oh, no.
We got slaughtered when we got on the Priori thing. We really got slaughtered. And that's how that all got broken up. They ran Bob right out of the country to save it. He fled to keep his life and tore everything we were doing up. And obviously they didn't want that Priori thing gone at all. They called these doctors that were going to fund it. We had $16 million of funding already pledged by some very wealthy doctors that knew this was real because he had cured cancer and put it in hard French literature. So, and you know, replicated by other scientists working with him. So, strange people called all these doctors up and said, you know, if you put 1 penny in this, you and every member of your family will be killed, you know, and includes the children. If you think we're kidding, tell us which child you want to kill first. So in the space of 2 weeks, we didn't have any backing. We already had reached an agreement with Priori. So we didn't get to do it. Priori later had a stroke. Spent the last 2 years of his life, you know, basically out of it and helpless, and then died.
See, most people can't do this unless they have some kind of research funds. In other words, it's very important, even if you're a garage mechanic and you think you're going to do some kind of invention, what's the first thing you always run out of? Money. Mm-hmm. So you just have to stop your project. But I've been pretty fortunate in all this, you know, to receive grants and different funds to do all this. And so I accomplished it. You know, otherwise I wouldn't have been able to do it.
Yeah.
And so I just want everybody to remember that if they build this, that it just takes a little bit of money to do the research.
Yeah, and Priori was fortunate because the World Health Organization provided money for him, as did the French military.
Right, where Rife,
He didn't have anything like that?
well, he had bridges.
Yeah, okay.
He had Timken roller bearing in the beginning. But see, as the people infiltrated into his lab, things started to change around and change around and change around. And I don't, in Rife, said, I don't think Rife was really into, wanting to build a machine unless every one of these machines was tested by him in his laboratory
Yeah.
under his microscope. Now think about this. How many microscopes did he build? About 3. Some worked. Some people had trouble with them. There's one in the Smithsonian Institute. Why isn't that up and operating and we can view it?
Mm-hmm.
So what's actually missing? Now I do know, I'm not allowed to give the name, but I do know of a person that reconstructed the microscope and it does work. So I can say that here.
Yeah.
And
This is important to do the lab trials.
yes, of which I can't do because I'm not a medical doctor and I don't, attend some university where they have all this stuff. And I think even if I did, the work would be buried.
Uh-huh.
But Strecker did it, didn't he?
Yeah, Dr. Strecker was very interested in the microscope and, being able to kill viruses with frequencies. And you'll find out later in this movie, or this film, that Dr. Strecker had to put up with a lot like I did with John Crane. Because John Crane really did not have all the answers, and it was more or less Rife said things to him, but if John Crane would have had the answers, then he would have Rife would have never allowed him to just sell a frequency generator that you bought off the shelf. That wouldn't have been.
What do you mean if he had the answers?
If Rife would have known
Yeah.
exactly what the secret to the machine was
Uh-huh.
and understood it,
Yeah.
then John Crane would have never been able to.
Okay.
Rife would have just walked away from the deal.
Yeah. Okay.
Because to sell frequency generators off the shelf is nutty
Okay.
in a way. So I think that's what I have to say, Tony.
Okay.
And they can view the DVD. We've decided to move over because we're going to be looking at what the original wave looked like that Rife used, and then we're going to be looking at the sideband, on the spectrum analyzer,
Right.
so we can see all this. So anyway, if you look at this wave, it sort of looks like a square wave. You notice that?
Yes.
But it's not a square wave. This was actually made up from sine waves. All right, so let's go up here and look at what it was. This is actually the sine wave that's coming from his oscillator, and this is what it's producing with the gating.
Okay.
That's automatic when you modulate this.
Whose oscillator is this? Is this
And this is Rife. This is Hoyland. Basically, this is the Schoon machine, the Auburn Schoon machine, that is a copy of the Rife machine. This is not the original, but it's doing the same thing, and it had the correct frequencies. All right, now, one thing that I want to explain that Richard Hoyland used 3 different frequencies. He used 3.8 megahertz, and then he used 3.3, and I think he used 3.1 something on a later version. And of course, Crane changed all that to 4.8 or 4.6.
Why did you do that?
Well, he did it for the simple fact is that he didn't want to interfere in the 3 megahertz band.
Okay.
So anyway, here's the original oscillator and the way that it looked. So you can see here
Yeah.
that it's not an absolute clean wave,
Right.
right? Today we can do far better than that, and the bands are much cleaner and everything, but this is a working machine. This machine actually worked. And see, when they did the sideband, these are your sidebands,
Oh yeah.
okay? But with the piece of equipment that I have over there, the DS8, 815, we're going to see it much clearer.
Okay.
Okay, so I'm hoping that I've answered that, but let's go to the sideband calculator now. This can only be gotten on online at the Rife group,
Okay.
and you're going to have to search through a lot of stuff to get it, but it's actually it's downloadable once you join the group. Anyway, you can see down here it says input your carrier frequency. And see, it's got everything that's known to date that we have a number on in our system. So I'm going to change this carrier frequency to where my fundamental is, which is 31. And to where the end of my sweep generator is going to go out, which is 70,000. Because I want to cover a lot.
Okay.
I want to make sure that I can cover everything.
Okay.
And then I'm going to tell it to calculate, and these numbers change.
Oh, yeah, I
you
saw
just
that,
saw
yeah.
that change. Yeah. So now if I go look at cancer, right here, the BX virus, it's saying that Hoyland and Rife's original frequency was 1,607, 450. All right? And it says that the frequency that I'm going to be looking for on the analyzer is going to be 3214900,
Yes.
plus or minus, 1 meter,
Right.
which is cycles. So
Okay.
maybe a couple hundred cycles, right? So now if we click on this and we go to the graph for the audio signal that we're going to input, which is, by the way, you couldn't hear this. It's at 57,450. See? That's way above the hearing range.
Okay.
But the machine can hear it. So now, we open this up. We can see where we're generating our wave. This is what the oscillator's actually doing, although we're going to use a square wave, which is going to come out like this anyway. And it says at what I've chosen, I'm going to be at the second band.
Okay.
And when I hit this second band is when I hit that cancer virus.
Okay.
Now watch. If I go back, X that out, and I choose something different like anthrax. See, it's still this carrier frequency remains the same, and still the sweep generator remains going from 10,000 to 70,000.
Okay.
And then I just hit that, hit the graph. You can see
Oh, it goes on the
that
other
it's
side.
on the other side. See,
Yeah.
it doesn't make any difference. When we talk about generating these harmonics, right? You don't want to have your machine putting the correct frequency way out here because, see, there's no power.
Okay.
The power goes up on sort of a linear scale, not quite. But
So you want some of the
You
second,
wanna get
third,
it-
or maybe the fourth at the outside.
yes, you want to get it as close to the fundamental as you can
Okay.
because that's the most power.
Yeah.
All right, so let's look at a couple of more and then we'll turn around and spin at the analyzer and work with it. Okay, so let's go down to tetanus. And I always make it calculate over. So, okay, so now see, tetanus is up here too. You see, and it says that, why everybody chose 3100 is it gives you the most power in this band.
Okay. Okay.
Yeah, you see what I'm saying? Fundamental is rock solid. It's not going to move.
Yeah.
So you don't care about that. So let's go look at something out like typhoid, the rod. See? It's also showing it's up high.
Okay.
And it says rod.
Yeah.
And it says, if we look on the spectrum analyzer, this is the frequency we're looking for, 3037.800.
And that's still 1 meter or less.
Yeah. I mean, we can be,
Yeah.
since we're sweeping,
Yeah.
these are not going to be stationary like this.
Right.
They're going to be changing.
Yeah.
So eventually we're going to hit that.
Yeah.
All right, so let's get one that sort of changes form. See, it says it's in the first place here. Let's go one to show you a little bit less power, which would be tuberculosis rod. Now, these are the only two. Tuberculosis rod and tuberculosis virus. Rife said that once you kill the rod, if you do not kill the virus, the patient will go into toxemia.
Okay.
Because the virus will use the rod as food,
Okay.
and
Yeah.
its waste material is going to kill you.
Yeah.
All right, so let's look at it. Where it is now. See, it's
Oh, yeah.
see, it's down in the power band. So, by the way, by changing this fundamental frequency, Pat, you can actually move this up or move it down.
Okay.
But we're not looking for one specific thing.
Because we're sweeping.
We want to sweep so
Yeah.
we can get this whole range
Right.
of viruses and bacteria. And see, some of this is bacteria like the B. coli rod.
Why does it say 5 on that?
Where?
Sideband number 5?
Yeah, sideband number 5. It's going to be in the 5th position. Pretty sure that's what it means.
Oh,
Yep.
yeah. Okay.
See?
Yeah.
1, 2, 3, 4, 5.
Yeah.
And so
Okay.
remember what I said on our chart,
Yeah.
that if I divide it by this, I can just count 3 over or 2 over or 1 over.
So when you're sweeping,
Then it's different.
it doesn't lose power when it goes down like that.
No, as you sweep, you're going to run a frequency that's closer up,
Okay.
you know,
Yeah, yeah.
bigger to the fundamental. And let's look at that first, all right? Let's look at that now. And we can come back to this if we need more
Okay.
explanation on this fundamental frequency. Okay.
So by gating,
That means that the audio comes in and sort of kicks down the oscillator
Yeah.
to ground,
right,
and it goes off, and then it comes back on.
and so
And it causes these peaks.
after each packet there's a gate.
Yeah, see it here? See it?
Right, right.
Let me get it to where I want to see it.
So you're not sweeping here.
Yes, we are sweeping.
You are
See
sweeping.
it?
So everything is running through that. What we're seeing on that scope is everything?
Everything that's being transmitted right now,
Okay.
coming out of the machine. So you're actually looking at the packets there.
Okay, that's the combined.
Yeah, this looks a little bit different, but actually does the same thing, and a little bit more precise than what Rice's equipment did.
Right.
His was tube, this is digital, more solid state.
This is what's going into the patient.
Yes, that signal right there with these sharp spikes in.
Okay,
But he doesn't feel that.
right.
Anyway, yeah, this, we're going to use the B&K Precision 4140B 12 megahertz generator in the sweep function in the linear mode.
So that's providing.
It's a laboratory. It has stopped. It's just showing you that it's going to sweep here, see? And it's showing you that it's in the linear sweep, see it?
Okay,
See that line?
yeah, yeah.
It's saying we're sweeping from here to here in a linear range.
And then it comes back and sweeps it in.
Right, because if we stop this
Right.
for a moment, right, we just say stop. You see we're at a locked frequency there. And this made me better to see where it comes back down. See, it's ringing. Well, it's at a frequency where this is actually your packet
Right.
that I was showing you. To see these squares, they look like squares,
Yeah.
but out here, they're sine waves.
Yeah, yeah.
See? All right? And what that sine wave is actually doing that we're inputting from this linear generator, right, the sweep generator, is modulating the RF circuitry to distort the wave and cause sidebands. So, if we go back to linear,
And that's a blank part.
yeah, let's see if we can get this. There you go. I want to get it so you can see it good.
That's good. You can see that.
Yeah, when it goes down to the lower frequencies, see the gates?
Yeah.
It's kind of hard for the scope to trigger on it. it doesn't know. You know, we can force it, but it's not gonna do it. And see, once we have our trigger line down here, we're not gonna be able to see it
Yeah.
until we get it to where it can catch a peak.
You can see it in that.
Yeah. So there's our packets, see?
Yep.
And the gates in between. So technically, it's identical to what Wright was doing.
How many times a minute were you sweeping it?
I'm going from 10,000. Well, where was it here? Sorry. Just stop that. Okay, we've stopped at 60,000. So our stop is 60,000, our start is 15,000 here. And our rate is 11.8 seconds.
Okay. So every 11.8 seconds is one sweep.
Yeah,
So
it's
that-
going to go through the whole thing.
So that's about 60 times.
Yeah.
Six times a minute.
Yeah.
Yeah.
So now we go back to sweep.
Right.
Go, and you can see that, well, we didn't stop the sweep, so it's still sweeping. But if we stop the sweep and we bring this out, you can see that it's all in here in packets. See? There's one complete
Yeah.
set of cycles that it's modulating on this thing.
Right.
And these sharp spikes are what actually get in there and kill the virus. Now we go back to linear sweep.
I have a question.
Mm-hmm.
If it sweeps every 11.8 seconds, so that's about 5 times a minute,
Yeah,
and your blood flows through your body, takes a minute for your blood flow.
Right.
If you did a 3-minute treatment, then you'd have 3 times 11,
yeah.
or 11.
Yeah, it's going to
Yeah,
hit it over and
exactly.
over. Right.
Yeah.
Yeah, it's going to hit it over and over, Pat.
Okay.
Now, let's go down here to this spectrum analyzer because I froze the screen here so that you could see what it's generating. And if I mark it, it's going to tell me right where this marker is. Can you see that there,
Yep.
Tony? Okay. And if I say that I want to look at the cancer frequency, we both know that we want to be at 3214. So see, I'm already past it. See, 32. So I can dial it in here, see? Okay, now see, I'm at 3214666 because the span. In other words, if I change the span, this number will get lower or higher. You understand what I'm saying? If I make the span go out, so I'm within 1/10 of 1 meter because I'm going to hit it when I sweep. So now let's look at what it's doing on the spectrum analyzer by unfreezing it. And see, I'm leaving the trace up there so you can see where we dialed in. But now see, on the second trace is in blue. See it hitting the cancer frequency each time, coming up to the resonant point.
So you're combining an actual sweep with
I'm leaving,
where do you set the original?
right, I'm showing you how it sweeps out, right? How it's going and
Right.
hitting that in the third place or the second place. See it? 1, 2, watch. The biggest one will be number 2, coming up right now. Right there.
Yep.
Yeah.
Okay. So now
Green is, yeah. Okay.
if we go back. Okay, so now we're on a blue screen instead of the yellow screen because that's the one we set to do the sweeping. All right. So now, Tony, let's pick a frequency. Let's freeze this when it's up here. So we'll wait a second here. All right, let's just say right there. See, now we've frozen, the yellow shows up as being there. So let's just clear all. Okay, so we're there. All right, now there's your fundamental frequency. We'll mark it. 3-1, see? And now what we want to do is we want to take that span and we want to zoom out so we can get as many of these bands as we can in there, see? And then what we're going to do is we're going to amplify this up so we can see we don't need this much attenuation. We'll change the scale division. And we're in the log scale, so it's going to go. Okay, so let's freeze it and calculate some things here. So we've frozen the screen and we've marked our fundamental. As soon as I move this around a little bit, I can show right where I'm at with the fundamental frequency. You know, which I'm close enough. So now if we go to the chart and you pick one out, like you talked about pneumonia. Remember?
Right.
So you can see what we're looking for is 2988034.
Okay.
All right. So now if we take the analyzer, and since we marked 2988, we'll just go 2988. We'll get 89499. We'll be within the range when we sweep. So now we'll clear this. The dot's right here. See it? We'll go in and we'll unfreeze this. Now, watch as this comes, the dot comes up as the side bands get bigger and bigger and bigger. And you see it's going to end up exactly what the chart's showing you. And it's going to hit it right when it needs to hit it.
Yeah.
The freezes, it has to rescan. So let's see if we can get this in a little bit better here. And that we would have to do by spanning it. There we go. Is that a little bit better on the camera?
Mm-hmm.
And you can see how many times it's actually hitting that pneumonia frequency. It's done it 3 times already. See, it's hitting it first in the low, and then it's building, and building. And so you can choose any one you want
When
there.
it drops to, that's the gate, is it?
No, the gating's done up here.
Okay.
But the spectrum analyzer, since you're sweeping, right, it's changing its frequency, modulating this. So you see it's getting narrower or bigger.
Okay, I guess I was just confused because it goes to the top and it goes to the top, but then it comes
Well,
right down
each
to the
time it goes to the top, you've hit the frequency.
Yeah, but it doesn't always come right down to the bottom, it seems.
Well, it does.
It does? Oh, okay.
Well, yeah, if you can't see it, see, look,
Yeah,
it's
yeah.
going all the way to the bottom.
Okay.
So pick another frequency, and I'll freeze this out, and we'll see if it hits it.
Gonorrhea. Why not?
Okay, let me stop it.
It's 3.029.
Okay, 3.029. Okay, 3.029.
Right.
Right.
3 zeros after that.
Yeah, that's fine, because see where it is on there, Tony? It's going to sweep it and hit it. So now we go back and unfreeze that. See it hit it with it hit it there, it hit it there. It's going to hit it there, but it's going to hit it with the most power here.
Yeah. Okay.
Because it's just going to be short of this one, watch. See?
Yeah.
Unless we change the span. But that's probably, it's going to hit it right where the chart says. So let's look at where the chart says it's going to hit it. Okay, so second band.
Right, and that's what it was.
That's what it's the second band that's going to hit it the highest here, Tony. If we watch. It's not going to hit it on the first band. It's going to start over. We're going to wait until it builds, see? But meanwhile, it's hitting it all that time. So it's going to hit this in the second band, which is right here. Watch. See, it's at the second band that it's got the most power. It won't hit it here.
Yeah.
Now, we might be able to tighten this in. But it's gonna show you all these generations. I want to go back to the marker. Okay, so we're looking for the second band, which is the highest, which is right there, because it's not going to hit it there. And that's basically how it works. So now just pick another random one, Pat. These are tough ones. Tuberculosis, virus C. Well, that's going to come in the first band. Well, we should show them this come up in the first band.
Right, we should. You're right. Yeah.
Okay, and so the frequency we're looking for is this one, 3076.
Right.
I think we did that.
We did the rod. We didn't do the virus.
All right.
The rod's, I think, on the 3.
Well, that's going to look kind of weird.
No, because he said you have to do both. So
Yeah, you have to do both,
Right. So,
because one will kill you. Okay, so what I'm going to do is freeze this again. All right, now what frequency are we looking for, Pat?
3076 hertz.
wait, what is this?
Well, this is the tuberculosis virus we're looking for here with the marker.
Okay.
So we're going to start the sweep. We're going to go back and unfreeze this. All right, we've hit it there on the first band, Pat. And so we hit it right away. See? We hit it there. And notice that as they spread out, we've already hit it, and see it's right there where the fundamental is. So let's change the span a little bit while this is running, so we can actually get it better. There's the fundamental. See it hit it?
Yeah.
And so we don't have to be right on here, because it sweeps it. It's going to hit it no matter what.
Yeah, yeah.
And it's going to hit it 6 times every minute.
Yeah.
Or is it 12?
Well,
No,
every
about-
11 seconds.
Yeah,
Every
every
11, so it's
11.
about 5 times every minute.
Yeah.
Yeah, see? So it's already hit it 2 times.
Okay.
There it hits it there. And it grows. Remember, it's sweeping by. It hits it right there. See, and it's furthest.
Yeah, yeah.
And then you see them go out from there because of the sweep. But actually, what's happening here is that this, we might be able to get this. I want to get it in a clear view. Now notice this is on the antenna. And when I touch it, see the power go up?
Yeah, yeah.
Because the signal's actually transmitting into me right now. So it's pretty powerful right there.
Yeah.
And then the other thing that I want to say is this is mandatory. This is a mandatory item to have, so that you know that when you make this unit from the little booklet and the video, that you can actually see all this.
So you're saying that you should really have the...
You should have the equipment to do it.
System analyzer, yeah.
Yeah, now this, you asked
Yeah.
what this was. This is the pump wave.
Okay.
And this is at 7.4 hertz.
Okay.
And that's generating a magnetic field right now in the antenna in the box. So the whole unit's actually in the box, or you can run electrodes on. It doesn't make any difference.
Well, that box is a little different than from the other one.
Yes, we'll cover that later on. But
What, in another DVD?
yeah, absolutely,
Okay.
because since we've, you keep thinking of things to do to this,
Yeah.
and it's never ending because it just doesn't, it's not that it has to be done this way.
Mm-hmm.
Here's what's going on. Now you really must think about what I'm going to say to you here. That nature, if we just disconnect, turn this off, and we bring this up. You see these frequencies?
Mm-hmm.
This is in the air.
Yeah.
See, it's hitting the Cancer and it's hitting the type. But what's happening is it's being masked by everything that we're using today, the computer, the digital switching supplies, these lights. If we really look at this, if we say we plug in that frequency that Cancer is, which is 107.455. But we have to tell it frequency, so we gotta go to a frequency of 107.455 and tell it megahertz. Now what it's going to do is it's just going to look for that frequency.
Mm-hmm.
And so what we want to do is 107. Well, it's way down here at this end. So that means we have to bring in this span. So if we go here to the Cancer virus, they want 1607, see?
450, right?
Yeah, so they want 16. And it's going to be out here somewhere. Now the funny thing about the spectrum analyzer is I think we can tell it center frequency. So if we push that, so what is it exactly, Pat?
1607.450 hertz.
4 kilohertz or megahertz, yeah.
Hertz.
Okay, so now see, Tony,
Yeah.
you can see that it's detecting that frequency right here when it goes up.
Yeah.
Because I think if we mark that, actually it's not telling us here. So let's just go back and set this again. Okay, there's our fundamental.
Okay. Yeah.
Okay. Let's see what we're doing here. But I think, you see this fundamental right here?
Mm-hmm.
Pat, there's something here that the antenna is picking up. So if we mark that, what it is 518.2.
That's in the natural background.
Well, that's not the natural background.
Yeah.
That's in the natural background right there.
Right.
518.2 megahertz. Something's transmitting.
Right.
See? So if we take this, right, and let's say,
That's the camera sound.
well, it could be.
No, it is. That's that frequency, 518.2.
Okay,
Sorry.
fine. Well, that's there. See?
Yeah.
It's actually picking it up.
Yeah.
Okay, now, if, say that a radio station, right? Say we wanted a radio station, just to give you an idea of what you could do with
I
it.
mean, I can cut the sound and do it off the other mic, but
Yeah. But you're picking this up.
Yeah. Let's
Yeah.
just take that demonstrates that's what
Yeah,
it is.
that's what I'm trying to do. I'm trying to demonstrate to you how it does, what it can do
yeah. But
here.
I think what you're trying to also demonstrate is the fact that all the healing frequencies are in the natural background
Noise.
noise, but we have polluted them so badly.
Yeah, we've polluted them because see, they're all in this noise.
And that's why there is so much more cancer these days than there was 200 years ago.
Now, here's a radio station. See,
Okay.
Right.
that's at fit 150. See, it's at 1.5 megahertz.
Yeah.
Right.
That's an AM station here. So let's see if we can get. These are all radio stations, Pat.
Okay.
So this is what I'm trying to show you, that we've actually polluted ourselves out from anything that which naturally would have healed us before.
Right.
So let's see if zoom in and get these.
Meanwhile, Congress is auctioning off all those frequencies
Yeah, exactly. Too.
to the highest bidder,
Yeah.
so they can pollute and cause even more cancer.
Well, yeah, this is what I'm trying to say to you here. That so if we just auto this, let's just say that we went from 900 kilohertz, right? So we can catch Rife's frequencies, all right? So if our start frequency is 900 kilohertz, and our stop frequency is going to be 2 megahertz. That's all we're looking at right now.
Yeah.
That's, see the frequencies in here?
Yeah.
The peaks. So now if we marker this, so we want for the cancer frequency, we want 1607, right? See 666? See it's coming up on the peak here? Okay, so you could, this is just something that I'm going to bring up to everybody. You could build a crystal filter that just picks this up right here.
Picks what up?
Picks the cancer frequency up
Right.
and amplify that, and all you'd have to do is pulse that, and you would have the machine for cancer. If Rife's frequencies are on.
Yeah.
Right. If not, it'd miss it.
If on, it would miss it, but you'd want to sweep this a little bit so
Right.
you do, you know, back and forth.
So you could have one machine for cancer, one for tuberculosis.
You could.
One for
Yeah, the virus.
Different crystals.
different crystals.
Yeah, you would want to hit the rod and the virus at the same time, so you'd need to combine those two.
Got anthrax or
Yeah, you could do that.
Yeah.
Because, see, it's already existing.
right,
Those frequencies are already existing in the noise.
right.
So it's a matter of amplifying the noise. And I'm not sure that this is amplified. Yes, RF preamps on. So all we have to do now is change this attenuation. We're at 2 dB there. Scale division there. Now we can see them much bigger, see? So see, look, it's already there, Pat. And there's multiples in there.
Yeah.
So it's like scanning itself. You notice that,
Yeah,
Tony, that they're jumping around. So if you built a crystal filter that just filtered this,
yeah,
and if we just filter this, and this is blocked out and that's blocked out, and we amplify this, and then we pulse it, there's his cancer.
Yeah.
yeah.
So that's what I got to say.
Assuming that Rife's.
Well, I'm pretty sure that he did.
Yeah.
Well, if you scan a certain, if you scan above and below it a little ways, then
Yeah, you'll hit it. If you filter this out, and that means building a crystal filter,
Right.
and that filter ignores this end and that end,
Yeah. Yeah.
and just lets this come through. Now you amplify that, and you pulse that, and you can see the bands in here. I don't know if we can span that out.
Yeah, well,
Okay, see, notice that?
Mhm.
See? It's scanning it, it's moving around itself.
Yeah.
So it's hitting it. See it here?
It's bouncing up and down the.
Yeah, let's change this, and then we can, if we change this scale to move it up so you can see it. So see the dot? And see, it's like a double
Finds the
peak.
stair and gets up there.
So I know that these natural healing frequencies were already in the noise that surrounds us.
And so this, just to recap, you're actually amplifying the natural noise that's around
Yeah.
us right now,
And I'm hitting his frequency.
and you're hitting the cancer frequency.
Yeah.
Yeah.
And see, if I take the marker, it's telling me. I can look at all the frequencies I can hit. Like you said, you see here's these peaks.
Yeah.
If this happens to be one of his frequencies, I can amplify that.
Yeah.
Yeah.
See, or I could go over here and I could look at this one. It's already there.
Just not,
Nature has supplied everything that we need to keep ourselves healthy, but the problem is we're masking all this out.
So am I correct in thinking that's why 200 years ago whatever, there were far fewer illnesses like cancer?
Yeah, there were far fewer illnesses. I mean, but once you got an illness, they didn't have anything to cure you.
Right.
You just died.
Yeah.
So basically that's, what I wanted to present to you was that you can hit it. And here's the machine here, Tony, that's doing the work. And this is
But that's what we're going to talk about in the next.
yeah, that's what we're going to talk about, this one in the next
Right. Okay.
machine, because it's more like a
So we might even take that out.
Peoria
from
machine.
this thing.
I'll just give it a quick.
Yeah.
And like Tony said, this guy is well documented in France.
Right.
Yeah.
And so I'm glad I could share this with everybody.
Okay. Well, I think everybody owes you a great debt of gratitude, John, for not trying to patent this work and not trying to hide it from the public, but for bringing it out
Yeah.
to the public. And as I said, I think everyone owes you an incredible debt of gratitude.
Well, I think they're going to need it here coming up in the future.
Well, and on that uplifting note, we'll we'll end this segment.
Okay. Tom would have said, have a good day now. Okay, this is I want to explain to everybody, this is a MOPA, and you can see inside there that it's a tube. This is exactly what Rife's unit was. This is a remake. And it's very critical that everything matches up on this, because it's very difficult to get the signals in and out of, because it's just a triode tube. It's much easier with a solid state unit. But anyway, let's have a go at it. Let's turn it on, and we'll see if we can catch the fundamental first. And there's the fundamental frequency, and it's actually scanning. So let's see here. Let's get this up. Let's find out where it is, so we can set the generator. Okay, this one's oscillating. Now watch as I turn this. I'm going to change the direction.
What are you turning?
I'm turning the tuning so I can get the fundamental above 3, see?
Okay.
So now I'm going to mark that. And I'm at 279. See? Marker. Now this is an outband way out there, Tony. See as I tune this? Okay, now it's sweeping. See, it's modulating and sweeping.
So this has a pump wave.
No, this is a straight Rife unit.
Okay.
And there's the bands.
Right.
And see, now it's modulating.
Okay.
And these are the frequencies that it's scanning and hitting. So it looks a little bit different here on this unit. And I'm going to scan this out. I'm going to attempt to scan it out. See how it looks?
Yep.
And you can see that it's scanning here, and then it'll reappear when it comes back, because it's hitting those bands. See? It's hitting all these bands, and then bang. And there's the tube over there. It's lit up.
So this is the actual tube you're using?
Yes, that's, yeah, and I'm right now I'm running from 50 to, and you can feel that, you know. You can see that it's a little bit different. And it's actually scanning all the frequencies right up here. And there are those packets again, see? See 'em? And I'm doing that the best I can do with this because this is just definitely antique.
When did you build this?
Well, I built this back in 2000 when we were all working on Jeff Garf and the rest of us were all working on it, and you can see that it's doing its thing.
I'm getting some interferences.
Oh yeah, you don't want to do that.
I get too close.
Don't get too close because the RF's going to burn your chip in your camera.
Yeah.
So let's take it away so you can see that it's really there.
What is this now?
Well, I just turned it off so you can see that that when it scans and gets the bands,
Okay.
you know, you gotta get this thing up. See, it's barely lit right now because I've got it turned way down because I don't want to burn things up. But here, you can see it here. We'll out of this and I'll hold on to it. There you go. See it? Pretty good, huh? Well, you can see it scanning the frequencies there.
Okay.
See? So that's exactly what Hoyland was doing. And it's scanning, you know, the generators. It's changing it, see it?
Right.
See?
So just to reiterate, Hoyland was actually scanning.
Hoyland, no. One specific frequency.
Okay.
I am sweeping
Okay.
so that you can see the bands appear on the MOPA.
Got it. And then on the upper scope, we're seeing.
You're seeing the packets. See as it scans? It's kind of hard to get it in because it's the, there you go.
Okay. Yeah, I'm getting RF interference.
Yes, see, yeah, don't get too close to
Yeah,
it.
yeah.
So see, you can see here that it's sweeping.
Yeah.
And I've got the power turned down, and this tube is quite hot. So what the doctors would do would hold the tube like this in the area, and then they would sweep the dial.
That's what Rife's doctors would do.
Yeah, they would, like if you had something here, they would hold the tube here.
Right.
See? And now I'm scanning all these frequencies. So who knows what it's doing? It's probably affecting my Stevie Wonder glasses.
It's affecting the camera.
I know, because it's real RF. I mean, it's you know, this is a big oscillator compared to the solid state.
Right.
Okay, this is your tank coil. And you, by tapping this, you can get different power levels to the tube. This is a triode tube. And then, of course, you've got your RF choke here and your tuning, where you can tune the fundamental frequency a little bit. Filament transformer and power transformer.
Okay.
And then your audio is, I've got it on clip lead, so but it actually goes in here. And the antenna is hooked up out here. So when you turn it on, it lights up. And then if we take the, I'm going to hold it so I can get the best signal there. And it takes a while for it to warm up. That's the problem with them.
Yeah.
Is they drift around for a while until they probably have to add the signal. There we go. Once the analyzer's caught it, then you can see it sweep. it's going to sweep and make the same bands.
Yep, good.
Okay.
Okay.
Thank you all.
Thank you, John.
I'm glad I could show you this.
Well, it's nice to see the way, you've been developing this process.
Well, since 1975,
Yeah,
I've been working on it, so
yeah. And,
there you go.
Thank you.